Good morning, everyone. So, now to answer the burning question. Why did a BA do a deep dive into facial verification? Well, it's a long story, so let me give you a summary. But, sorry, just give me a second. But first, hi, I'm Kayley, and I'm a junior business analyst at Standard Bank. Now, this all started when I was bored, as I usually am, and I was told I need to find a hobby. Now, when you think of a hobby, you can think of baking, sewing, running, if you're that way inclined, and, a few other things. Well, I did what any sane person would do, and I started spamming that person's WhatsApp, particularly using a Python script and a false number to remind them to pay the extended warranty. So, yeah, if you annoy me, just make sure I don't have your WhatsApp number because I might be spamming you with messages. But I only realized a bit later that this is actually illegal, and WhatsApp's rate limiting is very strict, leading me to almost getting blocked. Now, this little stint reminded me of how exciting programming can be. I studied informatics in university, so I have dabbled a bit, but I have to say it wasn't my favorite subject, as with looming practicals and tutorials, it wasn't that fun. But when you don't have that stuff, it's actually very enjoyable. But back to the story. I did as I was advised, and I put my WhatsApp spamming, well, days behind me. And I was thinking, what can my next project be? And what could I do specifically that would be fun and wouldn't end up with me getting blacklisted? Then I received a call from my gran asking for advice on how to verify her on her banking app. Now, just to paint an image, this isn't actually my gran, but I thought it was a cute photo. My gran is 80. She doesn't have the best hand-eye coordination, and she wears glasses. So imagine you're trying to verify your face with one hand, moving your head in multiple different ways, all without being able to see the screen because you don't have your glasses. But at the same time, oh, that jumped. At the same time, my client work had just kicked off a new project, and that incorporated facial verification. Well, as you can see, things were lining up, and that inspired me to try and see how this tech, or at least the algorithm behind facial verification, works. So the first step was to find something I could do quickly. As I mentioned earlier, I get very bored. And when I get bored, I do stuff that might not be legal. But anyway, so I get bored very easily, and I wanted something that was a quick fix. Now, I was going to put cocaine, like a photo of cocaine, but I thought that wasn't too PG. So here's a motorcycle. So I went to my favorite teacher, Google, and started looking for projects and tutorials. And I stumbled upon a project that would put a box around any face in real time just using your webcam. To do this, I installed I installed a model called OpenCV, which I discovered is a part of the field of computer vision, which is not what you get when you do deployments at 1 o'clock in the morning. Computer vision is a branch of computer science aimed at enabling computers to recognize and interpret objects and people and through videos and images. So OpenCV has this pre-trained model called car cascades, which has been trained to detect patterns in images. So using my webcam, I was able to capture the real-time images and plug them into the algorithm. Now, before you plug them into an algorithm, it goes through a function it goes through something called grayscale, which takes away all the colors from that image, as we're only really interested in the image and not any of the fancy color stuff. Now, who can tell me what represents a face? What am I looking for? It's an open question. No, Kieran, no idea. Mate, we all have one. So a face, well, according at least to this algorithm, has eyes, nose, and a mouth. And when those are detected, we put a box around these features. And this is run in a continuous loop. And that's how we get this. Just need to stop sharing. Go. That's how we get this. Sorry, let me just run it quickly. Awesome. Now, if you can see this on the screen, there you go. So I was able to do this. So it's actually taking photos every few seconds. So for us, it looks like, oh, this is just a continuous loop, but it's, yeah, taking photos. But as soon as I turn away and it can't see both of my eyes, and it's like, oh, you're no longer a person. So it's not perfect, but it was a really cool project to start. And I have to say that's one thing we can work on is making Microsoft stuff a bit quicker, but that's just a personal preference. So yeah, now while my PowerPoint loads and I get to the right slide. So while this was fun, I still wanted to do more, as this was a pre-trained algorithm, which was very handy and really good to understand how the inputs and outputs work. It wasn't exactly what I wanted to do. I wanted to create the algorithm myself. So I went back, with this in mind, I went back to Google and I stumbled upon a tutorial by Nicholas Renette, who in 12 hours, don't worry, I watched on 3 times the speed, I am a COVID student, explains how he creates a facial verification platform. Through this tutorial, he creates a sister or a Siamese neural network, as described in a paper made by the Department of Computer Science in the University of Toronto. This process allows you to collect your own images and pass them through a self-trained twin neural network. To create this algorithm, I needed to take 5 important steps. Number 1, I needed to collect images for my data corpus. Specifically, I needed to collect positive, anchor, and negative images. So these were from our BBD 40th birthday. So yeah, if I ask for a photo, there might be other meanings behind it. But anyway, so what happens is our anchor is what we want to get. These are verified images. So we say, okay, this person is allowed to access whatever. Then the positives are, we know it's a positive match to your anchor. So that's one part of training done. And negatives, we just chuck in a negative in there just to make sure that it's okay and that the algorithm actually works and doesn't just let anyone in. Images neural network consists of multiple layers, as you can see in the table behind me. And I have to say, I learned about all these algorithms all these layers while I was creating it. So lots of reading. And then once the images have made it through the layers in the parallel convolutional neural network, the distance layer calculates whether the images match. So if it's a 1, it's a positive and it's a match. If it's a 0, it's a negative and it's not a match. Now that the layers of the sister neural network were created, I took 70% of the data corpus and trained the model. This was done in multiple batches. And once the neural network reached an accuracy and precision of 100%, because I'm an overachiever, I moved on to the most exciting part, which was testing. Now, this involved me taking photos with my webcam and uploading them to the neural network and running them through to see if they were a match or not. Now, if this has kind of confused you and made you look a bit like this person, so you're tired and your brain's a bit sore, let me just show you what happened to my laptop when I was trying to train this model. This is my laptop, and that's an air conditioner. So good news, I was able to train the model, and it did work. I just had to use the air conditioner in the training room for 25 minutes to make sure that my computer didn't overload. Well, overload or overheat, because that model chows your GPU space. So this process, well, for me, was very technical. So in our grad, we have a technique where we say, okay, we don't understand this thing, so let's see how we can explain it to a 5-year-old. So I'm going to do just that. So imagine you have these special glasses. These are the twin network. And then you have your 3 favorite toys: your car, which is the anchor image, a truck, and a teddy bear. So now if you're wanting to go and see which one is the closest to your anchor image, you would hold up the teddy bear and the truck at the same time to the glasses, because it's a parallel process, and it will be, oh, the truck is a match. And that is what Nicholas Renette was trying to teach you in 12 hours, and I did that in about 3 seconds. Hopefully you all understood. But he also did it with some really cool code, so I really encourage you guys to go and check him out if you would like. So this process was really interesting and highlighted some key things to me. 1, I should probably use a more powerful tool than Jupyter Notebook, something like Google Colab, which won't eat your GPU space and will actually speed up the algorithm with regards to training and testing. And then while this algorithm worked really well for me and helped me understand the process, it struggles with a few things. Like, for example, if your anchor images or the images that you're using to verify against were taken in different lighting to images that you want to match, then it won't work. This is the problem, because imagine you trying to get into your iPhone using your face scan. and it says, oh no, we can't let you in because there's load shedding. So the lighting's a bit dodgy. So this is something I could probably work on. And then while I was focusing on the network and the data and everything that goes into it, if you want to do this in client work, or even if you want to show it to maybe someone that is not that technically experienced, then you might want to create a user interface. Now, the algorithm took me about a week to code. If I were to do the user interface, that would probably take me 2 months. That is not where my talents lie, so I focused on the algorithm. And then lastly, while I enjoyed data processing, preparing and setting up the data was a huge and tedious task. I had to take numerous photos from various different angles, and it felt a bit like a very off-brand Vogue photo shoot that I did at 1 o'clock in the morning. So finding a better way to collect the data would be very helpful. This journey began with me spamming my friend's WhatsApp and ended up with me diving into peer-reviewed articles, which I vowed after my honors I would not do again. But it's helped me, at least from a BA perspective, understand this process better. While there are many ways to grasp a process without overheating your laptop or binge watching YouTube tutorials, practical involvement is crucial for BAs. Understanding the tech deeply, even from a theoretical point, allows you to add more value to your end user and also allows us not to overpromise stuff that our developers can't create. I always ask for practical examples when I'm learning because that's something I just do. That's how my brain works, which is why I ended up coding this process. But regardless of how you learn, I encourage everyone in tech to dive deeply in to dive in and gain a deeper understanding of this technology. Of this technology or any technology you use. And if you have a question or task, go for it. Who knows, you might come face to face with something really cool. Thank you.